shall look into conversion of Boolean expression into 3 address code, and apart from that we will take some more exercises for practice. So, the example that we take for Boolean expression is like this. So, A and B or C and not of D, that is basically A, B or C, D bar. So, corresponding to this Boolean expression, how can we generate the code, that we will see. So, the grammar, if we first thing is to draw the parse tree. So, the since we have got AND at the top, so this will be B and M B, then this B will give me ID which is A, then this M will give me epsilon, and then this B should give me within bracket B. Okay. Now, the next this B will give me the OR. So, B or M B. Now, this B will give ID which is B, this M will give epsilon. Now, this B will give me the AND function. So, it is B and M B, this B will give ID which is C, this M will give epsilon, this B will give not of B, this B will give not of B, and this B will give me ID which is D. So, this is the parse tree. So, if I number the reduction, so this reduction will be done first, then this one, then it will do this one, then this one, then this, then this, then it will do this reduction, then it will do this one, then it will do this reduction and reduction, then it will do the OR reduction. So, this is number 10, then this is number 11, finally, this is number 12. Now, we have to consult the semantic action for this Boolean expression, and accordingly we have to generate the corresponding code. So, if I make some sort of a table like reduction number then the corresponding action and the code that is generated. Do it like this. Then at reduction number 1, so if we look into the Boolean expression rule grammar, then it says B first one is B 1 and M B 2. So, sorry, reduction number 1 is B producing ID. So, for B producing ID, the corresponding rule is this one. So, here it is not written, but in some other slide it will be there, but for B producing ID, so it generates a code which is if A, if ID go to, this go to will be filled up, at number 2 it will generate go to which will be filled up, and here it will produce this true list and false list. So, B dot true list is equal to 1 and B dot false list equal to 2. Okay. So, this will be done at reduction number 1. At reduction number 2, that is M producing epsilon, the only action is M dot quad is equal to next quad which is 3, that is done at reduction number 2. At reduction number 3, again we have got this B producing ID. So, 2 lines of code will be generated if B go to be filled up later, and this go to be filled up later, and the action is that B dot true list is equal to 3 and B dot false list is equal to 4. Now, reduction number 4 is M producing epsilon. So, it will do M dot quad equal to next quad, that is equal to 5. Now, reduction number 6, reduction number 5. So, reduction number 5 is again M producing ID. So, it will generate 2 lines of code if C go to unknown, this part will be filled up later and this is the else part. So, this is and accordingly it will generate true list and false list. B dot true list equal to 5 and B dot false list is equal to 6. So, this is at reduction number 5. At reduction number 6 is M producing epsilon. So, M dot quad M dot quad equal to next quad, that is 7. So, this is done. At reduction number 7 again B producing ID. So, it will generate lines of code if D go to and go to. Now, at reduction number 7 this true list and false list will be generated. B dot true list equal to 7 and B dot false list equal to 8. Now, reduction number 8, not of B. So, here the false list and true list they will get interchanged. So, B dot true list will be equal to 8, B dot true list equal to 8 and B dot false list equal to 7. At reduction 9, so B and M B2, so it will first of all, so the AND rule if we see B and, so this is the B and, so it first says backpatch B1 true list with M dot quad. So, that backpatching will be done M dot B dot true list. So, B dot true list is 5, B dot true list is this 5. So, 5 true list. So, that is true list, you have got 5 here. So, this location will get corrected now. So, that will be filled up with this M dot quad. So, M dot quad for this M producing epsilon line number 6. So, it is 7. So, this 5th location will get corrected. So, it will have a code correction where this 5th line will be modified like if C go to 7. So, this correction is done, this is the correction, and then it will be having this B dot true list, B dot true list will be made equal to whatever true list we have with from the second B. So, this 8 true list, that is equal to 8, and B dot false list, this will be merger of this B1 false list and B2 false list, that is 5 and 8 false list. So, 5 false list is 6 and this is 7. So, 6 and 7 will get merged. So, you will get false list as this one. So, this is reduction number 9. At reduction number 10, so this B OR, and for B OR again there is a backpatching. So, for B OR, so it is backpatch B1 false list with M quad. So, B1 false list. So, this is reduction 3, reduction 3 false list is 4. So, that will be corrected. So, the location 4 will now get corrected with go to that code will be modified. So, it will become go to 5, because this this m producing epsilon is 4. So, corresponding m dot quad is 5. So, this 5 is filled up. So, this is again another backpatching that is done, and then this true list and false list. So, B dot true list will be merger of the true lists. So, B dot true list will be merger of this 3 and this 9. So, these two true lists will be merged. So, 3 true list is 3, okay, and 9 true list is 8. So, 3 and 8 will get merged. So, to create the true list, and B dot false list will be B 2 dot false list, that is 6 and 7. So, this is done at reduction number 10. At reduction number 11 is within bracket B. So, this true list and false list will get copied. So, B dot true list equal to 3 8 and B dot false list equal to 6 7. So, they are copied, and at reduction number 12. So, this is again AND. So, first of all there will be a backpatching, and then it will do something. So, AND, so it will backpatch B 1 true list with M quad. So, B 1 true list. So, B 1 true list, that is 1 true list is 1. So, it will backpatch with this 3, okay, M quad is 3. So, this backpatching will be done, that is line number 1 will get corrected. So, it will be corrected like if A go to 3, okay, and then B dot true list and B dot false list will be created. B dot true list will be B 2 dot true list, that is 3 and 8, and B dot false list will be merger of two false lists. So, this is the merger of this false list of 1 and false list of 11. So, false list of 1 is 2 and false list of 11 is 6 and 7. So, they are all merged. So, this is the this completes the code generation part. So, you can just write down the final code that is generated. So, the overall code that is generated is like this at offset at index 1. So, we have got if A go to 3, then 2 we have go to, and this is not yet filled up. At 3 we have if B go to, not yet filled up. At 4 it is go to 5, okay, 4 it is go to 5. At 5 it is if C go to 7. At 8 we have at 6 we have go to. At 7 we will have if D go to. At 8 we have go to, and then if you consult this final true list and false list. So, this one and 3 and 8. So, 3 and 8. So, they will constitute the final true list. So, this 3 and 8 will give me the true list, and this 2 6 7 they give me the false list. This 2 6 and 7 they together will give the false list for the overall Boolean expression. Fine. So, you see that so now if you try to match. So, if A, then you need to evaluate the second part. So, if A go to 3, now it is checking here. If B, so A and B both are true, so it goes to the true list. Otherwise, if A is false, then it definitely false, so it goes to the false list. Fine. Similarly, if B is false, okay, it comes to 5, and now it checks C. If C is true, then it goes to 7. Here it checks if D, then it goes to false list. So, if not of D, it will come to line number 8. So, that will go to the true list. So, in this way, this piece of code is correct for the original Boolean expression that we had, and this 3 address code generation process. So, it has successfully been able to generate the corresponding code. So, next we will look into an array conversion. So, this for the array conversion, it is slightly tricky in the sense that so it is array conversion is slightly tricky because the number of rules that we have is more. So, we will try to do it. So, let us see how this can be done. So, let us consider an array reference like this, say A I j equal to B of C I j plus C I j plus D I into j. Suppose this is the overall Boolean expression, and this array has A has got dimension d1 d2, B is of B is a single dimensional array. So, B is of dimension d3, C is a 2 dimensional array. So, that is d4 d5, and again D is a 1 dimensional array. So, that is say d6. Okay. Now, the state, if we try to generate the corresponding parse tree. So, this will be S producing, this is an assignment statement. So, we have got this left side assigned as some expression. Now, this left side I have to generate this A I j. For generating this A I j, so this is E list bracket close, then this E list generates E list comma E list comma E. So, this E list generates ID bracket start E, this E generates L generates ID. So, this ID is your I, this ID is J. This ID is A, this name of the array A. So, this ID is I, this ID is I. Now, this E produces L produces ID. So, this is the J part. Now, for the right hand side I have got an expression. So, it is E plus E. So, from the first E I have to generate this of so then this E can give me this left hand side. So, E producing L producing E list bracket close, then this E list produces ID bracket start and E, this ID is B. Now, this E gives L and this L will give that E list bracket close. So, this L will give me E list bracket close, this E list will give E list comma E, and then this E list will give ID bracket start E, this ID is your C, this ID is that C array C. Now, this E will give me L, which will in turn give ID, that is your I, and this E will give L, that will give ID, which is J. Fine. So, so this plus part we have done. Now, that C I j plus D star I j. So, that for that part again I have to have this E plus E, and from the first E I have to generate this C I j. So, for this I have to go like L producing E list bracket close, E list giving E list comma E, then this E list giving ID bracket start E. This ID is C. Now, this E gives me L, gives me ID, which is your I, and this E will give L, will give ID, which is J. Fine. Now, this plus E, so this will again give E producing L, L producing E list bracket close, then this E list will give ID bracket start E. So, this ID is D. Now, this E gives E star E, this will give E star E. So, this will give E producing L producing ID. So, that is your I, and this E will give L producing ID, that is your J. So, this is the full parts tree that will be produced. Now, if I want to number it, so first reduction is this one, then this 1, 2, 3, okay. Then it will do a reduction of this one, then this one 4, 5, then this reduction 6, then this reduction 7. So, up to this much will be done, then it will be coming to this L producing ID. So, that will be 8. Now, this is 9. So, this is 10. Now, this is 11, this is 12, this is 13, this is 14, this is 15, this is 16, this is 17, 18. Okay. Now, it will be doing this one 19, then 20, 21, 22, 23, 24, then it will come down here 25. Okay. Okay, so it will be so 25, 26. Oh, sorry, there is a, so this is not 22. So, this will be 22, this will be 22. So, this will be 23. Okay. After that, this will be 24. Yes. So, this is 24, this is 25, this is 26. Now, this L producing ID, so this will be 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. So, this will be the whole parts tree with reduction numbers written. Now, if we try to write down the code generated and the reduction numbers corresponding to that, so it will be something like this. So, this is the reduction number. So, this is action and the code that is generated. Okay, code generated. Now, at reduction 1 we have this one L producing ID. So, accordingly it will have this L dot place equal to I and L dot offset equal to null. This will be null and no code is generated. At reduction 2, it will have this E producing L. So, E dot place equal to L dot place. So, E dot place equal to I, still no code generated. At reduction number 3, it will reduction number 3. So, there is an array. So, with the E list, so it will associate E list dot array as A, then E list dot place as I, and E list dot dimension equal to 1, dimension equal to 1. So, this is reduction number 3. At reduction number 4, it is doing this L producing ID. So, again same thing, L dot place equal to J and L dot offset equal to null. At reduction number 5, it will place that E dot place. So, at reduction number 5, we have this one E producing L. So, E dot place will be equal to L dot place, that is J, that is reduction number 5. At reduction number 6, so it will have E list dot array. At reduction number 6, it will have E list dot array equal to A, then E list dot place will be a new temporary T 1 and E list dot dimension will be equal to 2, and it will generate a code that T 1 equal to I into D 2 and T 1 equal to T 1 plus J. So, these two lines of code, if you consult the corresponding array rules, then these two lines of code will be generated. Now, reduction number 7, it will do L dot place equal to I and L dot offset equal to null, and it will have this T 2 at reduction number 7. So, L dot place will be equal to a new temporary T 2 and L dot offset will be equal to another new temporary T 3, and then T 2 is equal to the constant part of A and T 3 equal to T 1 multiplied by width. So, we assume that width of all elements are same, all arrays. So, then at 8, it will have at reduction number 8. So, L producing ID. So, L dot offset equal to I and L dot place equal to I and L dot offset equal to null. At reduction number 9, we will have this E dot place equal to L dot place. So, this E dot place is equal to I. Okay. So, that way it will do up to reduction number 9. At reduction number 10, it will have this that is this one. So, E list etcetera. So, this E list dot array will be equal to C, because this is a C array, then E list dot place equal to I, E list dot place equal to I and E list dot dimension will be equal to 1. So, no code is generated here. Reduction number 11. So, L dot place equal to J and L dot offset equal to null. at reduction number 12 it will do E dot place. So, at reduction number 12 is this one, E dot place equal to L dot place. So, that is equal to J. So, this way it will continue. So, we will continue with this example in the next class.